Imagine waking up tomorrow morning, reaching for your phone, and finding it dead. Not just out of battery, dead. You flip the light switch. Nothing. You look outside, and the entire city is dark. Cars won't start. The internet is gone. The water pumps have stopped. Within 48 hours, the grocery shelves are empty. Within a week, modern civilization as we know it has collapsed. This isn't the plot of a science fiction movie. This is a reality we missed by a margin of just 9 days in the year 2012. We like to think of Earth as a fortress, a safe blue marble floating in a quiet void. But the truth is, we are living in a cosmic shooting gallery. From invisible magnetic storms to mountain-sized rocks moving at 40,000 miles per hour, our planet has been in the crosshairs more times than you realize. Today, we are going to walk through the 6 most terrifying moments in recorded history where humanity stood on the brink of annihilation, and sheer luck, or one person's courage, brought us back from the edge. If you want to understand how fragile our existence really is, and you want to support high-quality educational content, hit that follow button right now. You won't want to miss what's coming. Let's look at the 6 times Earth cheated death. To understand our first near miss, we have to go back to a time before the iPhone, before the grid, and before the internet. The year was 1859. On the morning of September 1st, British astronomer Richard Carrington was observing the sun through his telescope. He saw 2 patches of intensely bright white light erupt from a sunspot group. He didn't know it yet, but he had just witnessed a massive coronal mass ejection, or CME. Here is the science you need to know. The sun is a giant ball of plasma entangled in magnetic fields. Occasionally, these magnetic field lines tangle, cross, and reconnect, a process literally called magnetic reconnection. When they snap, they release a burst of energy equivalent to millions of hydrogen bombs, hurling a cloud of plasma into space. Usually, these clouds take days to reach Earth. The Carrington event moved so fast it arrived in just 17.6 hours. When it slammed into Earth's magnetic shield, the magnetosphere, it caused a geomagnetic storm of epic proportions. The aurora borealis, usually only seen in the far north, was seen as far south as the Caribbean and Hawaii. It was so bright that miners in the Rocky Mountains woke up at 1 a.m. and started making breakfast, thinking it was morning. But here is where it gets dangerous. The storm created geomagnetically induced currents. In 1859, the only major electrical technology was the telegraph. Telegraph systems across Europe and North America failed. But they didn't just stop working, they turned into weapons. Telegraph pylons threw sparks. Operators received electric shocks through their equipment. Some telegraph paper caught fire. In some cases, operators found they could unplug the batteries and still send messages, powered entirely by the electricity flowing through the air from the aurora. Now, why is this on our list of avoided disasters? Because in 1859, a fried telegraph wire was an inconvenience. If a Carrington-class event hit Earth today, it wouldn't just be an inconvenience. It would be the internet apocalypse. Modern studies by Lloyds of London and atmospheric scientists suggest that a storm of this magnitude today would melt the copper windings of giant transformers that form the backbone of our power grid. These transformers take months, sometimes years, to build. If they blow, we aren't talking about a few days without power. We are looking at a blackout lasting 4 to 10 years. No banking, no refrigeration for food or medicine, no water pumping. It would effectively send the developed world back to the Middle Ages instantly. We survived 1859 because we were low-tech. We narrowly avoid this scenario every time the solar cycle peaks. If the Carrington event was a warning shot from the sun, this next event was a shotgun blast from the dark. In August 1883, a Mexican astronomer named José Bonilla was preparing to study the sun at the Zacatecas Observatory. While peering through his telescope, he saw something that shouldn't have been there. He saw fuzzy objects passing directly across the face of the sun. He didn't just see one or two. Over the next 2 days, Bonilla counted 447 distinct objects crossing the solar disk. He took photographs, some of the earliest astronomical photos ever taken, showing these strange, misty smears. For 100 years, the scientific community ignored him. They thought he had dirt on his lens, or that he was seeing birds or insects high in the atmosphere. The Bonilla observation became a footnote in history. That is, until 2011. Researchers from the National Autonomous University of Mexico reanalyzed Bonilla's data. They calculated the parallax, the speed, and the distance. Their conclusion was terrifying. Bonilla hadn't seen birds. He had witnessed a massive billion-ton comet that had shattered into fragments. And these fragments weren't far away. They were passing extremely close to Earth. The study estimates that these fragments ranged in size from 50 meters to nearly a kilometer wide. For context, the rock that killed the dinosaurs was about 10 kilometers wide. But Bonilla saw hundreds of smaller ones. If Earth and this comet stream had intersected, which missed by a mere hair's breadth in cosmic terms, it wouldn't have been one impact. It would have been a bombardment. Imagine 400 nuclear-sized explosions detonating across the planet over the course of 48 hours. It would have been an impact winter event. Dust and ash would have been thrown into the stratosphere, blocking out the sun for years, killing crops, and freezing the oceans. The Bonilla objects passed between the Earth and the Moon. We didn't have radar. We didn't have rockets. We didn't even know they were there until a man with a telescope saw their silhouettes against the sun. We drifted through a minefield and didn't even know it. Our first two disasters were natural. This next one was entirely man-made. This is the story of how human intuition saved us from algorithms. The date was September 26, 1983. The Cold War was at its absolute freezing point. The Soviet Union was paranoid, convinced that the United States was planning a first strike. In a secret bunker near Moscow, a lieutenant colonel of the Soviet Air Defense Forces named Stanislav Petrov was on duty. His job was to monitor the early warning satellite system called OKO, or the Eye. Suddenly, the siren wailed. The screen flashed a single, terrifying word: launch. The system reported that the United States had launched an intercontinental ballistic missile. Petrov froze. Protocol was clear. He was supposed to report the launch to his superiors immediately. If he did, the Soviet leadership, already on a hair trigger, would almost certainly order a full-scale nuclear retaliation. Petrov looked at the data. The system claimed one missile had been launched. He reasoned with himself. If the Americans were going to start a war, they wouldn't fire just one missile. They would fire hundreds to wipe us out before we could respond. He decided it was a glitch. He cleared the alarm. But then, the siren screamed again. And again. The system now showed 5 missiles inbound. The room was in chaos. His subordinates were looking at him, waiting for the order to notify the Kremlin. The computer calculated the probability of attack at 100%. Petrov was sweating. He had minutes to decide. If he was wrong, millions of his countrymen would die in a fireball without warning. If he was right and he reported it, he would trigger the end of human civilization. Petrov trusted his gut over the machine. He realized that 5 missiles still made no sense for a first strike. It was too few. He picked up the phone to headquarters and reported a system malfunction. He sat and waited. If the missiles were real, they would detonate over the Soviet Union in about 15 minutes. 15 minutes passed. Silence. No explosions. It turned out that the satellite had mistaken the sun's reflection off the tops of high-altitude clouds for the thermal signature of missile launches. If Petrov had followed orders, if he had been a machine instead of a human, a full-scale nuclear exchange would have occurred in 1983. Models of nuclear winter predict that the smoke from burning cities would rise into the stratosphere, dropping global temperatures by 20 to 30 degrees Celsius. Agriculture would vanish. 90% of humanity would have starved within 2 years. We owe our lives to the skepticism of one man. Remember the Carrington event we talked about earlier? The one that fried telegraphs in 1859? In July 2012, the sun pulled the trigger again. And this time, the gun was loaded with a bullet even larger than the one from 1859. NASA and space weather observatories watched in horror as a superstorm erupted from the sun. It was a complex eruption. 2 CMEs blasted out within 10 to 15 minutes of each other. The second wave caught up to the first, combining into a tsunami of plasma and magnetic energy. This wave tore through Earth's orbit at over 3,000 kilometers per second. The data collected by the Stereo A spacecraft, which was drifting in Earth's orbit, confirmed that this storm would have been catastrophic. Daniel Baker of the University of Colorado stated, "If it had hit, we would still be picking up the pieces." So, why are you watching this video on a working internet connection? Pure geometry. The storm crossed Earth's orbit exactly where the Earth had been just 9 days earlier. If the eruption had happened 1 week sooner, the Earth would have been squarely in the crosshairs. The National Academy of Sciences estimated the economic impact would have exceeded $2 trillion in the first year alone. Think about the supply chain crisis we faced in 2020. Now multiply that by 100. No fuel pumps, as they need electricity. No credit cards. No sewage treatment. Hospitals running on generators until the diesel runs out. We didn't avoid this because of technology. We didn't avoid it because of preparation. We avoided it because the Earth happened to be on the other side of the road when the bus drove by. When we think of asteroid impacts, we think of the extinction of the dinosaurs. But the universe throws rocks at us all the time. The scariest ones are the ones that explode before they even hit the ground. On June 30th, 1908, in the remote wilderness of Siberia, near the stony Tunguska River, the sky split open. A massive explosion flattened 80 million trees over an area of 2,150 square kilometers. That is an area larger than London. The shockwave went around the Earth twice. It registered on barometers in England. There was no crater. Scientists later realized it was a meteor airburst. A stony asteroid, roughly 50 to 60 meters wide, had entered the atmosphere and exploded under the pressure, releasing energy 1,000 times greater than the atomic bomb dropped on Hiroshima. The Tunguska event happened over an unpopulated forest. Only a few reindeer herders witnessed it. But if that asteroid had arrived just 4 hours and 47 minutes later, due to the Earth's rotation, the city of St. Petersburg would have been directly under the bullseye. The imperial capital of Russia would have been erased from the map. Hundreds of thousands would have died instantly. History would have been rewritten. But you might be thinking, that was 1908. We have telescopes now. Think again. In July 2019, an asteroid named 2019 OK buzzed the Earth. It was up to 130 meters wide, twice the size of the Tunguska object. It passed within 45,000 miles of Earth. In space terms, that is a kiss on the cheek. It was closer than our weather satellites. And here is the terrifying part. We didn't see it until 24 hours before it passed. It came from the direction of the sun, hidden in the glare, a blind spot for our telescopes. If 2019 OK had hit, it would have been a city killer. It wouldn't end civilization, but it could have wiped out a city the size of New York or Tokyo instantly. We avoided disaster not because we were smart, but because the cosmos missed. Our final disaster is different. It wasn't a sudden explosion or a missile. It was a slow, silent creeping death that we almost didn't catch in time. In the 1970s and 80s, scientists Mario Molina and F. Sherwood Rowland discovered something disturbing. Chemicals called chlorofluorocarbons, or CFCs, used in everything from refrigerators to hairspray, were floating into the upper atmosphere. There, struck by sunlight, they were breaking down and releasing chlorine. This chlorine was eating the ozone layer. The ozone layer is Earth's sunscreen. It blocks ultraviolet B radiation. Without it, DNA cooks. By the mid-1980s, scientists discovered a massive hole in the ozone layer over Antarctica. It was growing faster than any model had predicted. If humanity had continued business as usual, ignoring the science, we were on track for a total collapse of the ozone layer by 2050. NASA simulations show that by the year 2065, two-thirds of the ozone would have vanished. The UV radiation at mid-latitudes, like Washington, D.C. or London, would have been strong enough to cause sunburn in 5 minutes. Skin cancer rates would have skyrocketed, but the real killer would have been the food chain. High UV radiation kills phytoplankton in the ocean, the base of the marine food web. It also damages crops like wheat and rice. We were looking at a world of mass starvation and a human population forced to live indoors, venturing out only in thick protective suits. But this time, we didn't just get lucky. We acted. In 1987, the world signed the Montreal Protocol. It is the only time in history that every country on Earth agreed to phase out a damaging substance. Because of that agreement, the ozone hole is slowly healing. It is the single greatest proof that humanity can save itself if we listen to the data. When we look at these 6 events, a pattern emerges. We survived the solar storms of 1859 and 2012 by sheer luck of timing. We survived the comets of 1883 and the asteroid of 2019 because space is big and we are small. We survived the nuclear close call of 1983 because of human empathy. And we survived the ozone crisis because of scientific cooperation. It is easy to feel small when you hear these stories. It's easy to feel like we are just waiting for the next shoe to drop. But there is another way to look at it. We are learning. We are building better telescopes to spot the asteroids. We are hardening our power grids against solar flares. We are learning to value the delicate balance of our atmosphere. The universe is a dangerous place, but we are the first species in 4 billion years with the ability to foresee these disasters and, potentially, prevent them. Knowledge is our shield, and staying informed is the first step in that defense. If you enjoyed this deep dive into the fragility and resilience of our world, please give this video a like. It helps the algorithm share this knowledge with others. And most importantly, hit that subscribe and follow button and turn on notifications. We have a lot more mysteries of the universe to uncover, and you won't want to be in the dark when the next video drops. Until then, keep looking up.